Hey guys, welcome again. So in last tutorial we saw how to create a binary search tree, and in this tutorial we'll see how to delete a node in binary search tree. So that is again very good question, and people have somewhat difficulty in solving this question. So basically, as I have explained earlier, that BST is a tree where the left child is less than the parent node and the right child is greater than the parent node. So we can have the three options in while deleting the node. First, when the node has no child. So like this 1, 4, 7, 13, all those nodes have no child, right? The left and right are null. We can have another case when only one node is there, one child node is there. So either left child node or either the left child node. Or we can have the another case where all two childs are exist. So like 8. So 8 has both nodes 3 and 10. This 6 has both nodes 4 and 7. The 3 has 4 nodes 1 and 6. So we'll see that how to solve problem of all three cases, right? So while writing I will also explain that how we can do that. So first write a function. So that was about the inserting. If you want to see about the inserting, then you can see my previous tutorial where I have explained how we can insert the element. So write a function delete, and I will pass the root node. So that will be my root node, and that is my value which of which nodes I want to delete. Okay, so first what I want to see that if node equals to null. So let's say if the element which you are passing is null, then in this case we can simply return the null, right? But you can also return the okay. Now okay, let's terminate it. Debug was on. Okay, so now we check that because our aim is to reach till that element which is the element which you want to delete. So let's say first I want to delete this one, right? So my aim is to delete the delete till 3. So once I reach till 3, then I will simply remove this one, right? That is my aim. So what I will do for that, I will recursively go till the function till that node. So I will check that if the value is less than the node of data, because that is how I will check. So if it is node.data, then node.left, because that will be left. So delete node of left, and then simply pass the value, right? And if it is not, then in this case you can pass the else. So else if value is greater than node data, in this case we'll send it to the right section. Node of right, sorry, right, and then value. So what we are doing basically, we are reaching till that element, right? So else if I missed here, if so like you are checking, okay, like in this case 1, this will go here, it will send that this 1 is less than 8. So it will go node.left equal to delete node of left. So again this will call the function with the node 3. Again 1 is less than 3. So 1 is less than 3. So again it will send this. Again this will call this function 1. Now it will check that 1 is equals to 1, right? So that is our case, because now it will go again here and node is 1. So then we'll write else if this is the case. Now in this case we'll check that if node.left equals to null and node.right equals to null, Now in this case, if either node of left is null or either node of right is null, right? So first we'll check that what it has. So let's take a temporary function node left and check that if node dot left equals to null, so let's take it first as null, right? And then check that if node of left equals to null, then our temp will be node of right. Else if it is not null, then our case will be node of left. Okay, so what could be the possibility? It solves the three purpose. It first check if node of left is null or node of right is null, or if both are null, then it go inside this. It checks if node temp null, then it checks if temp equals to node of left is null. So like in this case node of left is null, so it will go to node of right, which is also null, right? So now we check that if temp equals to null, then return null. So what it would do, because this is a node of left, so this node is 3 and we recursively called the 1, so it will go here, it will come here, and that both elements are null, so simply return null. That's what we want. So in this case it checks if both are null, if temp equals to null, then return null, and if it is not null, so if the temp is not null, it means any of the node is there, any of the child node is there, either node of left is there or either node of right is there. In this case simply return the node. Right, so if you see this will fulfill both the condition. How? That first it check, like in this case both are null, so return null, so we'll return null and it will simply delete the one. But if any of the child is there, so like in this case 13 is there, so in this case return the node, so we are returning node, right? So that is the difference here. Okay, so now so first fulfill this condition, and at the last we have written node. So basically this hasn't solved the problem fully, because still we need to solve this problem, that when both the childs are there, right? So let's solve this. So we are saying else if this is the case, else, so if both childs are there, then we need to find the inorder successor, and once we find the inorder successor, then we will replace the item to that item, and then we'll finally delete that item. So I'll explain while solving the problem. So when it has the item, then first our aim is to get the successor. So we'll say successor equals to get successor, and here you can pass the node. So our aim is to get the inorder successor first of all. So what we do, let's say I want to get the inorder successor of 3. So the inorder successor is always that, because we know that the right child of this will always have the greater value, right? So like 6 is greater than 3, but the leftist child of the right child is always be the inorder successor. So like in this case the 4, because 6 is greater than 3, but all the values which are in left node, in the left subtree of this 6, will always be the lower value of 6. So it means the leftist child will always be the greater than this one and the less of this one. So we'll check if right of 3 is null, it means we'll simply return null, because there is no inorder successor. But if it is not null, it means 6 is there, and if the left of 6 is null, it means we'll simply return 6, because that will be our successor. But if it is not null, then we'll iteratively go till left of null and at the last we'll return the we'll get the copy of, we'll get the node, right? So that's what all we do. So what's do, first of all, write a function. So let's say public node get successor, and here you will pass the node. So let's say simply node, right? So first of all we'll check that whether if node is null or not. So if node is null, then simply return the null, because there is no point of solving. Now we'll check that for, let's say node.right or node temp equals to node of right. So we'll iterate the loop till if temp is not null. So we'll check if temp is not null, then go temp equals to temp null, temp sorry left. So we'll go again to left. So it will check that like in the first case, if this is node of right. So if temp is null, then in this case it will simply return the temp which is null. But if it is not null, so it will go inside this and it will check that temp equals to temp null. So let's say if this is a case, like if it go here, so the 4 is not null, so it will go temp equals to temp dot null. Now temp has become 4, so it will return temp, right? And suppose if this was null, if there was no value, so it will simply return out of the loop and it will return 6. So that will fulfill our condition, it will return our successor. So now we have got the successor, so we have got the 4. So what is our aim now? We will replace the value, so node of data to successor dot data. So what we'll do, we are copying the values. So now 3 will become 4, right? And now what we'll do, node of right will again recursively call this function with the value node of right, and you want to delete 4, right? So now our function has become that we have copied this 4 has become here, right? So implicitly, so basically we have deleted this 3 and we have copied the 4. Now I am passing the node of right, this node, and I want to delete 4. So now it's very easy, because we always know that 4 will be the this 4 will be having the no child, and it will be very easy to delete, because this always be this case that node of left is null and node of right is null. So again this will call this the delete function, and it will delete this one, and then after deleting it will return to node of right. So that is how it will go, and then we'll simply return node, right? So we have done enough coding, but now let's start that how to delete the function. So we'll start from the basic. So we'll call the root and we'll pass the parameter root. So a dot delete node, so it's root, and let's say I want to delete first one, which is very basic. So let's put a debug point here and let's go here. So now it's checking. So it's checking basically that if node is null, so no, node is not null, this is 8, right? So it will go here. Now 1 is less than node of data, so it will again call delete. Now our node is so our node is now 3. So again 1 is, because we are passing 1, so again 1 is less than 3, it will go here, again it will call here. Now node is 1 and value is also 1, right? So it will go again here. Now it will go in else. It will see that node of left is null as well as node of right is also null. So temp is null. Now you can see that both are null, so temp will always be null. So now if temp is null, so it will return null. It means this will return null, right? And if you see here, what is node? Node is 3. Now you see it, So the left of 3 has become now null because we returned the null value, right? So that is how we do that. That if it has no child, then simply return the null. So now it will return the null value and it will recursively call. So if you see this, 8 left 3 and left of 3 is null. Okay, now write a function. Now delete a value. Let's delete 14 because this has one child node null. So go here again. We have already done this. Now go here. So it will check that value is 14, so it will go in this case, right? Again it will call. So now again 14 is greater than this one, again it will go. Now 14 are equal, so it will check that temp equals to null. Now temp, so if you see this, temp is 13 because the node of left was not null. So now it will go in else and it will return node. So what it is doing basically, it is returning this 13 value to 10. So we are bypassing this 14, so the 14 will delete and this 13 will return to 10. So if you see the node is 10, and if you see this now, so the node of right has become the left is always null and the right was okay. So here we did a mistake because this node was no, we should return ideally the temp. So return here temp. So now what it will do, it's basically return the 13 because we were basically returning the 14 in this case, but we should ideally return the 13. So this 13 will return to 10. And now again run this and check that, because that is the best thing. When we solve the problem, then only we can get to know what is wrong in the problem. So again it will go here. Now when it matches, it will come here, it will see that it is not returned. And now if you check that the right is 13 because we have written the temp, and that is how we have removed the 14, right? So if you go here and if you do this, you can see that 8, so 8 of right is 10 and that 10 of right is 13, right? And now see a problem where you have the both the nodes. So let me remove this and simply write this. So let's say I want to delete 3 which has both child node. So let's debug this. Go here, it will again check that this is the case that node of left is a big, like this is not the case but the values are same. So now it will go in else because the both childs are there. So now it will go get successor. So let's go in get successor, and now our node is 3. So we are checking that node is not null, yes. And now temp is not right, so basically temp has become 6. So now it will again check, it will go till left of null. Now it will check that the left has become null. So again it will go here. Okay, so again we can't return null because the temp of not null. So what we do basically, we should check by temp of left, right? That if temp of left is not null, then do temp of left and then return temp, right? And if this is the case, then what we need to do, because we are checking this one, yeah, so this will work perfectly. So again call this one and go here. So get of successor, and now it will say node of right, so which is 6. So now it will check that the left is not null, then do temp equals to 4. Now the 4 of left is null, so it will go with this and it will return 4. So that is our successor. So if you see this, so what we have written, successor is 4. So now we'll replace the values. So now we have replaced the value and node of right. So again it will call the function and it will come here again. It will check that both the childs are null of this one, so it will return this one. Okay, so now if you see, that what was the node was 3. So because this is basically the 3 node which we have deleted, and the right is 1, right, and the right is 6. So if you see, the again the left of 6 has been zeros, right, which is the case because now 4 is deleted and it has only right node. So if you see this, only the right node is here and it will simply return. So if you check that, then we have successfully written the 3 value. So that is how we have seen that how to delete the all the 3 cases when you have the no child, when you have single child, and when you have both the child. So thanks friends for watching the video, and please subscribe the channel for more such videos, and in next tutorials we will see more such problems on BST.